how can you design a machine vision system for a defect identification solution, but you have a very limited set of defects? Can a solution actually be developed? Hi, my name is Raghava. I'm the CEO of Qualitas Technologies, and in this video I'm going to talk about some of the techniques and tricks you can use when you have a limited set of defects but you still want to deploy an AI-based vision inspection solution. One of the most common problems in manufacturing is that you will always see an imbalanced data set of having a large amount of good or acceptable parts being produced and a very small percentage of defects. And even in these defects, you're going to find, very little commonalities between them, because they may appear in different geometries, they may appear in different locations, they may appear in different visible structures, but it gives you a representative sample. However, that doesn't necessarily mean that they're always going to appear exactly in that shape or location when you're actually inspecting this in a production line. So how do you overcome this challenge? Now, this is where AI and machine learning training comes into the picture. So there are a couple of different ways. The first one is to actually augment the data. So you have a limited set, but you take sufficient number of images with those limited sets with maybe slightly different orientations and camera angles, with different exposures, or even with different resolutions. Having done that, you can further augment these using software techniques to skew the images and add some element of transformation to it, like different exposures, different skews, different scales, and different rotational angles, so that the same finite set of images then can further be multiplied into many more. So it's called augmentation. The other technique that you could use is to actually use some kind of a one-class detection technique. So in other words, you're training the system both with examples of good information as well as examples of bad information or defective information, and the system is learning what a good sample looks like, and it's looking for deviations from that good sample. So in other words, it's not learning the defects, but it's learning a pattern of a good or acceptable sample, and any deviations from that is going to be flagged. The third type, which is a new emerging technology, is synthetic data generation. So using some kind of artificial intelligence like generative adversarial networks or GANs, or even creating synthetic 3D models of your part and introducing defects using 3D modeling techniques can also be defined. It can also be used to generate multiple samples of defective images, which can then be fed into your AI or your deep learning model training pipeline. So there are emerging technologies which are really exciting that's coming out, which is going to make defect identification a lot easier to solve. And we at Qualitas, we're definitely watching all of these and employing one or more of these technologies to be able to make defect identification a lot easier. So hope this video was useful. Thanks, have a great day.